Hi, welcome back to the Virtual Planetarium at Raritan Valley Community College. My name is Kevin, and today we're going to be talking about the James Webb Space Telescope. But before we do that, let's talk about our upcoming moon phases. We have a first quarter moon on January 9th, we have a full moon on January 17th, and then we have a last quarter moon on January 25th. Now, like I said, today we're going to be talking about the James Webb Space Telescope. You've all probably heard about this, it's been in the news quite a little bit, but just in case you don't know about it, we'll talk a little bit more about it now. James Webb Telescope is going to be the next big telescope put together by NASA with the help of ESA and CSA, and it actually launched on December 25th of last year, and that was a long time coming already. It's basically the Hubble's replacement, but not quite. This telescope is almost 3 times bigger than Hubble, and it actually doesn't even observe in the same wavelength as Hubble. Hubble operated in visible light, which is the light that we can see with our eyes, but James Webb is going to operate in infrared light. So these are the colors of light that come before red, and we just can't see them with our eyes. What this means specifically is that where Hubble saw dust, James Webb is actually going to be able to see stars. Here we have a picture on top. Here is a picture from Hubble looking in visible light, and then down below we have another picture also from Hubble but looking more towards the infrared. And we see that the dust starts to disappear and we can see the stars behind it. So James Webb is going to be able to do this a whole lot better, so we're going to be able to see through this dust a whole lot better and see the things that are further and further away in our universe. James Webb is going to be so big and sensitive that we're hoping it'll be able to see the earliest galaxies and stars that formed after the Big Bang, so it's going to be looking really, really, really far away. Now, like I mentioned earlier, the telescope was finally launched on Christmas Day last year after almost 15 years of delay. This delay actually wasn't a totally bad thing because with all this time in between, they were able to redesign it and make the technology for it so much better, so we're actually going to be getting the most out of it that we can now. This telescope is incredibly sensitive and complicated. If you've seen pictures of the telescope, it kind of looks like a boat like we have right here. And that's because, like I've said before, this telescope is going to be observing in infrared light. Another way to think about infrared light is to think about heat. The boat-looking part at the bottom of the telescope right here is actually a giant heat shield. It's about the size of a tennis court, so it's really, really big, and it's going to be protecting the telescope from the sun. Our sun is really, really hot, so if it's out in outer space in direct sunlight, the telescope is going to be really hot, and we're not going to be able to see anything at all except the heat from the sun. So this sun shield we can see right here is actually 5 different ones right here, and this side at the bottom here is going to be facing towards the sun, and that part will reach about 230 degrees Fahrenheit. But the telescope side of our telescope right here, the mirror side, or this opposite side right here, is going to be protected by these very special 5 layers of insulation, and this other side of the telescope is going to be at about 380 degrees below zero. Only at that temperature will the mirror, and the sensitive instruments up here be able to detect the tiny, tiny signals from early in the universe. Here we have another view from the bottom of the boat right here. We can see again this side is the one that's going to be getting the sunlight, and that's why we also have some solar panels right here. And then the other side is going to be completely shielded from the sun and protected. Now, unlike Hubble, Webb isn't going to be orbiting close to the Earth. It's actually going to be in a special point on the Earth's orbit called L2, which stands for Lagrange point 2, which is almost 1 million miles past the Earth. But this special point in past the Earth's orbit means that as the Earth goes around the sun, the telescope is actually going to be going around the sun at the same speed. So it's always going to be in the same place with respect to the Earth and the sun. So that's pretty cool. What's even cooler is that it's not just going to be stuck in that point in space, it's actually going to be orbiting this point in space. So here we have a really cool animation courtesy of NASA, where we can see the really interesting and unique path that this telescope is going to be taking as it orbits around the sun, which is really, really cool. Thanks for joining us this week. Hope you learned something new. I'm going to put a lot of links in the description of this video with a lot of resources about the James Webb Telescope. I didn't go into that many details today, but it's a good introduction. And again, there's going to be a lot of fun stuff in the description of this video, so you can check those out if you want. And please stay tuned for some amazing science from this incredible feat of engineering. It's going to take about 5 more months of tuning and calibrating, so we won't really see any results for a while, but it's still really exciting to know what's coming, and especially after such a long process and such a long wait. So I can't wait to see literally what James Webb is going to be able to give to the science community. That's going to be so fun. Thanks again for joining us. If you like this video, be sure to give us a like, and if you haven't yet, please subscribe to our channel, and hope to see you next week.